Hello my dear students. Today we talk about Unit 2, Lesson 3, Motion. In this lesson, we will know what's meant by motion and its type. First, motion. Motion happens all around us. Every day we see objects like car, like bus, like person move in different directions and at different speed. So motion means object change its position. The object change its position as time passes. Means the object change from place to another as time passes. Okay? Look at this picture. And imagine if you are in the car A, the orange car, and the other car moves forward beside you, car B, blue car. You will imagine that your car moves backward. You imagine your car, the orange car, move backward. So you feel your move forward, backward, or at rest according to the other object. You feel your move according to the other object or relative to the fixed point. Okay? Also look at this figure. The traffic light called fixed point. So we said the bus move 5 meters per second from this point. We said the bus move 5 meters per second from the traffic point or from fixed point. Okay, so the object move related to the another object, and that is called relative motion. Okay, so the object move according to the other object is called relative motion. So relative motion means its change of an object's position or its direction as time passes in proportional to the another or a fixed point known as frame of reference relative to another object or relative to the fixed point known as frame of reference. The fixed point mean the fixed point called frame of reference. This fixed point used like traffic light. It's called frame of reference or fixed point. It's used to determine the object position or describe its movement. Okay? So, do you know what's mean by relative motion? Okay? It is change of object position or its direction as time passes relative to the another object or relative to the fixed point known as frame of reference. Okay? Second, we talk about types of motion. The motion of object is divided into two types: periodic motion, okay, and transitional motion. First, we talk about periodic motion. Periodic motion, it is motion which is regularly repeated in equal periods of time. This motion is repeated at equal periods of time. For example, vibrating motion as motion of pendulum. When the pendulum move, its motion repeated in equal periods of time. So vibrating motion from periodic motion. Okay? Number 2, circular motion. Circular motion such as fan arm while it is on. Circular motion like fan arm motion. It is a periodic motion. It is repeated in equal period of time. Also, from circular motion, movement of moon around the earth. Okay, it is considered as circular motion because it is repeated in equal period of time. Okay? And also wave motion, such as water waves. The wave motion, it's considered from periodic motion because it is repeated in equal periods of time. So first we talk about periodic motion. Periodic motion, it is motion repeated in equal period of time, like vibrating motion, circular motion, and wave motion. Okay? Second, we talk about transitional motion. Transitional motion like train motion, like bike motion, like car motion, like person motion. All this is called transitional motion. Transitional motion means the object change its position relative to the fixed point as time passes from initial position to the final position. Initial position means from start position to the final position to the end position. So the object changes its position from initial to final as time passes. This is called transitional motion. Okay? Like train motion, like bike motion, like person motion. So we have two types of motion, which are periodic motion, it is motion repeated in equal period of time, and transitional motion. Transitional motion, the object position change from initial position to the final position. Okay? After that, we will study wave motion as type of periodic motion. We will study wave motion. The waves causes motion. The waves causing wave motion are divided into two types. We have two types of waves that causing the wave motion, which are mechanical waves. We have two types of waves, mechanical waves and electromagnetic waves. Mechanical waves and electromagnetic waves. And to understand what's meant by each of them, we take some examples. Okay? For example, we receive sunlight. Sunlight reach on the Earth's surface. Why? Because light is from electromagnetic waves. Light from electromagnetic waves. The electromagnetic waves don't need medium to travel through. They can travel in all media and in free space, and their speed is very high. So mechanical waves, like light, doesn't need medium to travel through. Okay? We take another example. Astronauts can't hear each other's voice directly in space. Do you know astronauts can't hear each other's voices in space? Why? Because sound is from mechanical wave, and the mechanical wave need medium to transfer through. So mechanical waves like sound wave don't travel through space, and their speed is relatively low. Okay? And it produced due to vibration of medium. Mechanical wave produced from vibration of the medium particles. So it is called mechanical waves because medium of particle vibrate. So mechanical waves mean they are vibration of medium particle. It needs medium to transfer through. Its speed is relatively low. So if the waves need medium to transfer through and speed relatively low, and the medium particle is vibration, that is called mechanical waves. Example of mechanical waves: sound waves and water waves. Look at this is a sound waves. Sound wave need medium like water medium, okay? It need medium or air medium. So mechanical wave need medium to transfer through. While electromagnetic waves, they are accompanied with electromagnetic force. They spread out in all media and in space. Their speed are greater, are very high, can be accounted as 300 million meter per second, okay? And from example of electromagnetic waves: light waves, microwaves, radio waves, ultraviolet rays, infrared rays, and X-rays, okay? All this from electromagnetic waves. So we have two types of waves, which are mechanical waves like sound waves and water waves, electromagnetic waves like light waves, radio wave, ultraviolet, infrared, and X-rays, okay? We take this example to differentiate it between mechanical waves and electromagnetic waves. Lightning and thunder. Do you lightning like this in picture? Thunder that is accompanied with lightning, okay? Lightning and thunder. We see lightning before hearing the thunder. However, both of them occur at the same time. Lightning and thunder occur at the same time. But we see lightning before hearing thunder. Why? Or give reason. The answer: because lightning is from electromagnetic waves which have high speed, while sound of thunder is from mechanical waves which have low speed. Okay? Question 2. Astronauts can't hear each other's voices directly in space. Why? The answer: because sound is from mechanical waves which needs medium to transfer through. The mechanical waves can travel through space. So, astronauts can't hear each other's voice directly in space because sound is from mechanical waves which needs medium to transfer through. Okay? And we will study some technological application for mechanical waves and some technological application for electromagnetic waves. First, we talk some technological application of mechanical waves. Examining and carrying sets for human body using sound waves like this in picture. Okay, ultrasonic waves, and it's used in musical instruments like violin, lute, guitar, okay, and reed pipe. All this depend on mechanical waves, and also it is used in amplifiers and distributing sounds and controlling sounds used in broadcasting studios, okay, like this. Second, some technological application for electromagnetic waves. First, application on infrared rays. Infrared rays used in night vision apparatus, in remote sensing instruments, in cooking food, in remote sets control that operate electric sets like TV, okay. Application on ultraviolet rays. It's used to sterilizing the sets of surgical operation rooms, sterilizing the tools or sets in surgical operation rooms. Also, X-rays application, use in photographic bonds, use in examining mineral raw in industry, use in studying the inner structure of mineral crystal, like this in the pictures. Okay, and finally, gamma rays and visible light. Gamma rays used in medical purpose as treatment and discovering some tumors. Okay, like this. And visible light or seen light used in photographic cameras, in television cameras, and in show devices like data show. Okay, that's all. Thank you for listening and goodbye.